Hello, and welcome back to the Network Engineer Pathway. I am Sam, your lead tutor. Today, we are going to lay the absolute foundation for your entire career. We are tackling K61. This knowledge point is about the role and function of virtual or physical network components and typical topologies and service architectures. Think of this as learning to read the blueprint of a building. Before you can fix a leak or add a new room, you need to know where the walls are, where the pipes run, and what holds the roof up. In our world, those walls and pipes are routers, switches, and firewalls. Our goal today is to give you a clear, structural mental map of how networks are built, so you can navigate them with total confidence. Let's use my scaffold and ascend method to break this huge topic down. K61 is built on 3 distinct layers. Layer 1 is components. These are the bricks, the actual things that make up the network, whether you can kick them, physical, or they live in code, virtual. Layer 2 is topologies. This is the layout. It's how you arrange those bricks. Are they in a line, a circle, a star? This determines how data flows. Layer 3 is architectures. This is the grand design. It's the high-level strategy that dictates why we build the network this way in the first place. To be a professional network engineer, you cannot just know one layer. You must understand how the component fits into the topology, which supports the architecture. Let's start with layer 1, the physical components. This is the heavy iron you might see in a server room. First, the router. Think of this as the traffic cop. It sits at the edge of your network and directs traffic between different networks, like connecting your office to the internet. It operates at layer 3 using IP addresses. Next, the switch. This is the connector. It connects devices within the same network, like all the PCs in an office. It works mainly at layer 2 using MAC addresses. Then, the firewall. This is your security guard. It sits at the door and checks the ID of every packet trying to enter or leave. Finally, the wireless access point. This is essentially a radio that converts wired signals into Wi-Fi for your laptop. Now, the industry is shifting. We are moving from physical boxes to virtual components. This is called Network Function Virtualization, or NFV. Instead of buying a specific metal box to be a router, we write software that acts like a router and run it on a standard server. You will encounter virtual switches, vSwitches, inside hypervisors like VMware. They connect virtual machines together just like a physical switch connects physical PCs. The role is the same, directing traffic, but the form factor has changed. This gives us massive flexibility and speed. You can deploy a virtual router in seconds, whereas shipping a physical one takes weeks. Moving up to layer 2, topologies. This is the map of how things connect. The most common one you will see is the star topology. Imagine a central switch with cables radiating out to every desk. It's popular because if one cable breaks, only that one desk goes offline. It is easy to troubleshoot. Then there is the mesh topology. This is where devices connect to multiple other devices. We use this for high reliability, like the internet itself, because if one link fails, traffic can find another path. You might hear of bus or ring topologies. These are older, legacy designs. You rarely build them now, but you might find them in old buildings. Remember, if you can't draw the topology, you can't fix the network. Finally, layer 3, service architectures. This explains how the network delivers value. The classic model is client-server. Your laptop, client, asks a powerful machine, server, for email or files. Centralized and secure. Then there is peer-to-peer, where devices talk directly. It's resilient but a nightmare for security and management. The modern standard is cloud architecture. Instead of owning the server, you connect to it over the internet. And critically, the 3-tier architecture. This is how most web apps work. You have a presentation tier, what you see, an application tier, the logic, and a data tier, the database. As a network engineer, you need to secure the traffic between these tiers. Let's put this into practice. Imagine a client is moving into a new office. They need you to design the network. First, components. You specify 2 routers for redundancy. If one breaks, the other takes over, 4 switches to connect all the desks, and 10 access points for Wi-Fi coverage. Next, topology. You choose a star topology. You run cabling from every desk back to a central comms room. Why? Because it's easy to manage and reliable. Finally, architecture. The client uses Office 365 but keeps large video files locally. So, you design a hybrid cloud architecture. You have just used all 3 layers of K61 to solve a real-world problem. For your portfolio, K61 is perfect for a technical case study. Use the STAR method. Situation: the office Wi-Fi was slow and unreliable, especially in the meeting rooms. Task: I needed to diagnose the fault and upgrade the network. Action: I audited the network. I mapped the topology and discovered the access points were daisy-chained together, which is a bad design causing bottlenecks. I replaced the old components with new Wi-Fi 6 APs and recabled them into a proper star topology connected directly to the core switch. Result: Wi-Fi speeds increased by 300% and complaints stopped. Reflection: I learned that simply buying new hardware isn't enough. The underlying topology must be correct for performance. If you are doing your major project, K61 is mandatory for your technical design section. You must include a professional network topology diagram. Use tools like Visio. Label your components clearly. Distinguish between what is physical and what is virtual. Most importantly, justify your design. Right, I implemented a 3-tier architecture to segregate the database from the public internet, ensuring data security. This visual and written evidence proves you can translate abstract requirements into engineering reality. To conclude, remember that every network, from your home Wi-Fi to the global internet, is built on these 3 layers: components, topologies, and architectures. Whether the components are physical boxes or virtual code, their function remains the same: to route, switch, and secure data. Your value as a network engineer lies in your ability to choose the right combination of these blocks to build a solution that meets the client's needs. Master the blueprint, and you master the network. I challenge you to go home tonight and draw a diagram of your own home network. Identify the router, the switch, it's probably inside your router, and the topology. It starts there. Thank you for your focus, and I will see you in the next session. Thank you so much for joining me today. I hope you now feel more confident in mastering this topic. If you found value in this session, I have a small favor to ask. Please hit that subscribe button, give this video a like, and follow our channel. It really means a lot to me and helps the algorithm show these lessons to other apprentices, just like you, who need support. Don't forget, you can download today's slides and the full transcript at www.mentorinai.com EPA Hub. While you are there, check out our mock interview and portfolio review services to make sure you are fully ready for your EPA. See you in the next video. Keep learning.